Hello friends, welcome to the channel. So today we are going to discuss the first topic which is going to help us for the analysis of any kind of DC networks. Okay, this is named as mesh analysis. So the mesh analysis basically depends on the KVL. What is KVL? That is Kirchoff's voltage law. We all have know that what is KVL. Okay, so I am just writing the statement for KVL. We'll have a brief about the KVL, right? So what is KVL? Yes, so this is the statement for Kirchhoff's voltage law. What does the statement says? That the algebraic sum of all the electrical elements voltages in a closed electric path is 0. Okay, so for example, I have a circuit like this. The circuit should be in a closed path and it can be in any manner, whatever is the connection, but it should have a closed path. Okay, suppose this is my first element has the voltage of V1, second V2, then V3, V4 and V5. Okay, so here we can see that this circuit is closed. Okay, so we can apply the KVL here. Now what will be the KVL? It says that algebraic sum of all the electrical elements voltages in a closed electric path is 0. So the first condition that there should be a closed electrical path. You can see here is a closed electric path, so we can apply KVL. Now what will be the voltage here? That can be written as, that is V1 plus V2 plus V3 plus V4 plus V5 is 0. Okay, the simple statement that says that the summation of all the voltage, all the elements will be equals to 0. Okay, so here in a short form we can write that summation of voltages is 0. So this is the statement for KVL. Okay, now the same statement we are going to use for mesh analysis. Okay, there is a prerequisite that you should know what is mesh and what is a loop. Okay, I have explained that all the terminologies all the terminologies in the lecture that is named as network terminologies. If you have not watched, please go and watch that. So you should know that what is a mesh and what is a loop. Now we are going to see the mesh analysis. Okay. So now we are on the mesh analysis. So first of all, the mesh analysis is applicable on mesh only. We cannot apply for loop. Okay, that is the first condition for mesh analysis. So we should know that what is a mesh and what is a loop. We should be clear about that. Okay, so what is a mesh analysis? That again the same statement we can write for mesh analysis. What is that? That the algebraic sum of all the electrical elements voltages in a mesh is 0. Okay, now what we can write the statement as? So this is the statement for the mesh analysis. Again the same statement what we have used for KVL, but the difference is that now we have to apply this summation of electrical voltages in a mesh. Okay, and that will be equals to 0. So before going to the mesh analysis, we should know about the sign conventions. What sign conventions we are actually going to use while we are writing the equations for mesh analysis. Okay, so what are the sign conventions? So the first thing is that we have two types of elements, as we have discussed in the previous lecture, that is network terminologies. First is termed as the active elements and the second one is what? The passive elements. Okay, we have discussed it. Now what is active elements? Active elements are those elements which has the capacity to release the energy. Examples, any kind of sources. Okay, that can be a voltage source, that can be a current source. Now what is passive elements? Passive elements are those elements which consumes the energy. Okay, like we have resistors, inductors, capacitors, all that element comes under the category of passive elements. Okay, so if we have an electric circuit, then there should be combination of some electrical elements, and that combination must be there with some number of active elements and some number of passive elements. Okay, that is the common thing, that if there is some energy releasing source, there should be some energy consuming elements also. Okay, so we will always have the combination of active and passive elements in an electric circuit, right? Now, as I have told you that active elements are the sources which releases the energy, and passive elements are the elements which consumes the energy. Okay, so we can classify it in terms of energy. Okay, if I'll say that in the energy column that the active energy releases the energy, so if I'm showing you the releasing part with the plus sign, okay, so what about the consuming source? That should be opposite to this. That means what, right? That if plus is used to release the energy, then minus should be used to consume the energy. Okay, so this is the simple sign convention, the simple first thing of the sign convention, that the active elements are generally denoted by plus sign and the passive generally denoted by the minus sign. Okay, so now we'll have some examples. First of all, we'll see about the active elements. Okay, so I have told you that active elements are the elements which is used to release the energy, like sources. So we have two types of sources. We know that first is what? That is my voltage source. And what is other source? That is what? The current source. Okay, so we will see what are the sign convention for this. So what is the symbol for voltage source? We know there is a circular shape of symbol with some polarity indication. Okay, similarly we have the symbol for current source like this, because current is shown with the help of the direction. So the symbol consists of arrow which shows the direction of current. Okay, now we know that in a voltage source the current release with the positive sign. Okay, current releases with the positive electrode. So this will be the direction for current, right? And here in the current source, we know the current direction is upward according to this arrow direction, right? So this is the direction for current. Okay, so if I have to mention the voltage of this voltage source, suppose the voltage across this voltage source is Vs. Okay, and the voltage across this current source is Vi, suppose. Okay, so what will be the convention for this voltage source? If I am going to take the analysis, okay, now I have to take one more direction, that is my analysis direction. If I am going for the analysis in the upward direction, suppose this is my analysis direction, right? So you can see the analysis direction and the current direction are both same. Okay, what is analysis direction, how we are using this, I will explain you when we will go for some numerical examples. Just focus here whatever I am saying. Okay, so suppose my analysis direction and current releasing direction of the voltage source is same, then at that time the voltage of this source will be mentioned with plus sign. Okay, here we will mention it with the plus sign. So this is my first case when analysis is of the same direction to the current releasing direction. Now the similar thing will be there for the current source also, because it is also an active element. Okay, suppose here the analysis direction is again upward. This is my analysis direction. Okay, so what will be the voltage here? Voltage is Vi as indicated. So the sign convention for this will be again plus, because both direction are in same direction. Okay, so this is the first convention, right? Now what can be the next convention? That suppose my analysis direction is downward. Now I am going to analysis in this direction, downward direction. Okay, so this is my second case. So what about the second case? Here you can see the second case. In second case we are going to have the analysis in downward direction and the current releasing direction is upward. That is according to the voltage source. Okay, so now both are getting reversed. Because it is getting reversed, so that's why now for the second case the Vs will be mentioned with negative sign. Okay, when the both direction will be reversed, then we have to take the negative sign. Similarly, when we'll have the analysis direction suppose in downward direction, okay, so at that time what will be the voltage source sign convention? That will be taken as negative. So just these two things we have to remember, because active elements are the positive elements which is used to release the energy. So here when both the directions are same, at that time we will consider it as positive, otherwise it will be negative. Okay, so this is about the active element. Now we'll see about the passive element. Now what is passive element? As we have discussed, passive elements are the energy consuming elements, right? And examples for these are what? Resistors, inductors, capacitors, diodes, that all comes under the passive elements category. Now this is the passive element which consumes the energy. To represent that consumption of the energy, we use generally the negative sign with these elements. Okay, so what are the sign convention here? Here you need not to bother about where to take the plus sign, where to take the minus sign. That is the best thing about this, that always we are talking about the DC networks. Right now we are studying that. Okay, so we will always have the resistors here. So let's see about the resistor part. What is the symbol of resistor? This is the symbol. We represent the resistor like this. Okay, now the best thing about the passive elements that we need not to bother about the plus and minus sign. Generally, in general, always take the minus sign for the resistive element. Okay, because we are talking about the mesh analysis which depends on the voltage KVL. Okay, so we have to write the equation in terms of voltage. So suppose the current through this resistive element is I. I don't know what is the direction. Okay, suppose the current through the resistor is I. So what will be the voltage across this resistor? That is suppose VR. So that can be taken as IR. Okay. Now the first case, that suppose the analysis direction is like this. So if analysis direction is like this, so what to take the sign convention for this? That is to take as negative. Now second case, if my analysis direction is like this, then what should be the direction? What should be the convention for voltage here? That is again minus VR. Okay, so just keep remember that what should take the sign convention for active elements and always take negative signs for passive elements. That is the easiest way to solve or form the equation for mesh analysis, right? So this is the important thing about the sign convention parts, because with the help of sign convention only we can go for the equation formation of mesh analysis, right? So let's understand what is mesh analysis with the help of one example. Yes, so this is my example. We are at the first example for mesh analysis. Okay, so this is the circuit given and we have to get the values of mesh currents. The question is asking that find the values of mesh currents with the help of mesh analysis. So this is the question. Okay, so first just note down what should be the steps for mesh analysis. So steps for going the solution with the help of mesh analysis. So these are the 4 steps according to what we have to go. Okay, so first step says that identify the numbers of mesh. Now what is mesh? Mesh is a closed path. Okay, we have discussed it in previous lecture. Mesh is a closed path in an electrical circuit which doesn't contain any other loop inside it. Okay, means it should be an individual loop. उसके अंदर में और कोई दूसरा loop नहीं होना चाहिए. Right, so you can see here that this is a closed path. Okay, and inside this there is no other mesh, no other loop. So this is an individual loop which can be called as mesh. Similarly here this is also an individual loop. This can also be called as mesh. Okay, now I have one more loop. What is that? This is my another closed path which can be called as loop. Okay, but in this outer loop I can see there are 2 number of loops which is inside that loop. So it is not a mesh. Okay, that outer loop cannot be taken as mesh. So here we have 2 numbers of mesh. Okay, so if we have 2 numbers of mesh, so there will be 2 mesh currents. I am just giving the name to that mesh current. Okay, and if there are 2 number of mesh currents, then there will be 2 KVL equations, right? We have to write the KVL equation twice. Okay, so this is the first step we have completed. Now what is the second step? Take your analysis direction. Okay, that analysis direction, as you can see here, this is my first mesh and this is my second mesh. So to form the KVL equation, I should go for the analysis in any of the direction. The direction may be clockwise or it may be anti-clockwise. You can take in any manner. There is no problem. Okay, but just remember that in that analysis direction, we have to form our KVL equation. Okay, so here for the first instant, I am taking the clockwise direction. Right. Now, this is for the first mesh. Now, similar direction I am taking for the second mesh. You can take first as clockwise, second as anti-clockwise, whatever it is. Okay, that doesn't matter, but the KVL equation formation should be in that direction. Okay, so this is my second step. Now, third, form the KVL equation in each mesh. Now, we are at the KVL equation formation. We have to form for each mesh, right? So we have two mesh, that means we have to form the equation twice, first for first mesh and then for second mesh. So first of all, I am writing the KVL equation for mesh number 1. So in mesh number 1, this is my mesh 1. Here, how many electrical elements are connected? Yes, that is 3. First is electrical voltage source, second is resistor of 2 ohms, third is resistor of 1 ohm, right? So we have 3 elements, then that means there should be 3 values of voltages, right? Like we have written for KVL, that is V1, V2, V3. Okay, so there should be 3 voltage values. So for this instant, I am just writing it that voltage across 12 volt is suppose V12. Okay, then the voltage across the 2 ohm resistor is suppose V2 and voltage across the first 1 ohm resistor is V1. Suppose that is the convention. You can take any kind of convention. Okay, now KVL equation is what? The algebraic sum of all the voltages is 0. Right. Now we will identify that what is the voltage across this each element. Okay, so first element is 12 volt. Okay, see, you can see the voltage equation I have written in the same direction as I have taken for the analysis. Okay, first I have started with here, then this, right? So voltage across the 12 volt source is how much? That is 12 volt. Directly it is given because it is a voltage source. So we can write it as 12. Now what will be the sign convention, whether it is plus or minus? So you can check here. The large plate of the battery shows the positive direction and the small shows the negative direction. That is the simple symbol for voltage source. Okay, so here the current release with the positive plate, that means current release direction of the voltage source is like this, right? So here you can see the analysis direction is upward, the current releasing direction is upward, both are same, and this is an active element, that is positive element, that means I have to take the plus sign. So we can write the plus 12 here. Now what about the next, that is 2 ohm resistor. So what is the voltage across 2 ohm resistor? So I have taken that current is flowing how much, that is I1, I have represented it. Okay, so current is flowing through the resistor is I1. Now I have to mention the voltage across the resistor. So that will be what? Ohm's law, V equals to IR, right? So I is I1 and what is R value? That is 2 ohms. So I am writing it as 2I1. Okay. Now what to take the sign of this resistor? I have told you that for passive elements always take the negative sign. Right. Now what is my next element? That is 1 ohm resistor. Okay. So again we have to go for I into R. Right. Now here focus, the resistor 1 ohm is like this in the circuit. Okay. And here what is the value of current through this resistor? So here you can see the resistor is common for both mesh, right? It is connected with the first mesh as well as it is connected with the second mesh. So that means there will be combination of two current. What is that? That is I1, I1 is also flowing, and I2, I2 is also flowing through this 1 ohm resistor. So there is a combination of two currents, that is I1 and I2. Okay. So as I have taken my analysis direction, so according to my analysis, the current I1 is flowing like this. Okay. And according to the analysis of I2, the I2 is flowing like this. Okay. So here the direction of I1 and I2 is opposite. No problem. Now I am at the first mesh and my analysis direction is going like this. That means for 1 ohm resistor I have to go for downward. Okay. So I will take the net current through this 1 ohm resistor in the downward direction. So what should be the value for that? That is what? Simply I1 minus I2. Why I1 is plus? Because it is in the same direction downward and I2 is in opposite direction. So the current through the branch 1 ohm resistor is how much? That is I1 minus I2. Okay. So I know what is the current through the 1 ohm resistor. The resistive value is 1. So I into R is what? 1 ohm resistor into I1 minus I2. Okay. So need not to write this one here. Right. So this is the value for V1. Now what is the sign convention? Again it is an passive element. Just take negative sign. Okay. Now equals to 0. So this is the equation for first mesh. KVL equation for first mesh. Okay. So just we have to keep the equations here. Just we have to take the voltages values and we have to consider about this sign. What to take the signs. Right. So just I am resolving this equation. So what will the next line? That is 12 minus 2 and 1 is 3I1 and minus minus plus I2 equals to 0. Right. So this is my first equation. So I am giving the name for the first equation as 1. Now we are going for the equation formation in second mesh. What is my mesh number 2? This is right. So here how many electrical elements are connected? Again 3, 1 ohm resistor, 3 ohm resistor and 6 volt resistor. So again I have 3 elements, right? So I am just denoting it here as V1 for voltage across the 1 ohm resistor, then V3 for the voltage across the 3 ohm resistor and V6 for the voltage across 6 volt resistor. Okay, now we are applying KVL, so the summation will be equals to 0. Okay, so now we have to check what is the values of V1, V3 and V6. So what is V1? Again we have to go for separate analysis of V1 because voltage across 1 ohm resistor we have to consider, and this is the central branch which is connected with I1 and I2. The same case will happen whatever we have seen here for the second mesh also. Okay, so just focus again because something will be changed here. So this is my 1 ohm resistor. Now according to the analysis, the directions, this is for I1 and this is for I2, right? What is the changes here? See, in the second mesh I am considering the clockwise analysis. So now I am writing the mesh and KVL equation for the second mesh. That means I have to go according to this direction. Okay, so what is the direction of my analysis for the KVL formation in this mesh across the 1 ohm resistor is, that is upward. So now I have to write the KVL current value in terms of I1 and I2 in the direction of upward. Okay, so suppose here the current is I. So what is that? That is summation of I1 and I2. So we are going for the upward direction. That means this should be I2 minus I1. Okay, according to the sign directions we have shown. Right? So according to that, I will write my voltage equation, voltage value for this 1 ohm resistor. So that is what? I into R. What is I? That is I2 minus I1 for this case. What is the value of 1 ohm resistor? That is 1. So I am not writing here. And it is also a passive element. So what will be my sign convention? Take negative. Okay. After that, we'll go for the voltage for 3 ohm resistor. Resistive means passive element. I into R. What is the current value for this branch? That is simply I2, right? As we have taken for this mesh, that is I2. So here I into R is I2 into 3. Okay, so that is 3I2. Now again it is a passive element, resistive element. So the sign convention can be taken as negative. Now what about the last element, that is voltage across the 6 volt battery. So here the voltage is 6 volt. Okay, simply it is 6 because it is a voltage source. Right, now what about the sign convention? So let's focus on this. What is about the sign convention for voltage source? So here the voltage source branch is like this. This is my 6 volt battery. Okay, so here we know that the positive plate is the larger plate and the negative is the smaller plate. So according to that, what is my current releasing direction of this voltage source, that is I. Okay, this is direction given by the voltage source polarity. And what is my analysis direction in this mesh? You can see that is clockwise, and according to that we are going downward for the analysis in the voltage source. Okay, this is my analysis direction. So this is an active element. Okay, and active element, in active element we are having the reverse direction of current and analysis. That means we have to take the negative sign here. Okay, the condition has been changed as we have seen for 12 volt. There both the sign was positive, the current releasing direction of the battery as well as my analysis direction. So that was taken as positive. Okay, but here the current releasing direction is upward but the analysis direction is downward, right? So I have taken it as negative. So that is equals to 0. So this is the equation formation for second mesh, right? So now I am just resolving this for simple equation. So here this will be like -6 plus I1 and -4I2, that is equals to 0, right? So this is the second equation taken for the second mesh, given the equation name as 2. So now what is my fourth step? Fourth step is solve for the equation unknowns. What are the unknowns? I1 and I2 are the unknowns in these two equations. So now I am going to solve for equation 1 and 2. So here simply you have to take these two equations. Okay, you have two unknowns, so easily we can solve it and find the value of I1 and I2. Here you can use the conventional method to solve the equation, or better to use the calculator, because we are allowed to use the calculator. So we should be know to use the calculator in all the manner. Okay, so we should be able to solve the equation in that calculator also. I am going to make a separate video for that equation formation to make you learn about this. Okay, so for this instant solve it by yourself, these two equation. I am just giving the direct answer. Okay, so what is the answer? So this is the answer we got with the help of this two equation solution. So first I1 we are getting 3.818 amperes and I2 as minus 0.545 ampere. Okay, that means 3.818 ampere current is flowing here and minus 0.545 ampere current is flowing in this mesh. Okay, so just again give your attention here that the second answer is coming with negative sign. Why? Because the voltage source, we know the current releasing direction is upward, but the analysis direction we have taken downward. Okay, so the current value whatever we got, that is for this I2 in this given direction. Okay, whatever I have taken for the analysis, the answer coming for this direction, right? So that's why the negative sign is here, and that shows that our analysis direction is opposite to the actual flowing value. So there is no problem because we have mentioned the negative sign, that means the answer is right. Okay, so that's why you can take any of the analysis direction. According to that you have to form the KVL equation and you will get the answer according to that taken analysis direction only. Okay, so this is about our mesh analysis portion with one solved example. Right? Now we are going to have the next question, that is second question, and I am going to give this second question to you for practice. So this is the second question and I am going to give this question to you for practice. Again you can see here we have two mesh. Okay, so I1 and I2, two currents will flow. You can take your own direction, whatever you can go, you are going to take for analysis, either in clockwise or in anti-clockwise, whatever as you want. Okay, I am just going to give you hint so that you can solve by yourself. First try to solve by yourself and then check your equations with this. Okay, just pause the videos here and make your own equation according to your own direction and then check your equation with this solution. So this is the two equation, KVL equation. You can see here. Just check your answer with this and find the value of I1 and I2. Okay, so this is all about today's class. In the next lecture, we will have some more examples of mesh analysis, okay, with some complicated circuits. Okay, thank you all.